In this recording, we're going to look at how to verify trig identities. Before we do that, I have up here a list of the basic trig identities. We have the reciprocal identities, sine x equals 1 over cosecant x, etc. Quotient identities, tan x equals sine x over cosine x, and cotangent x equals cosine x over sine x. And the three Pythagorean identities, sine squared x plus cosine squared x equals 1, tan squared x plus 1 equals secant squared x, and 1 plus cotangent squared x equals cosecant squared x. So the reason I wanted to write these down is I would need to keep these next to me when I'm doing these trig identities. So let's try and verify the following identity. Secant squared x minus tan x cotan x equals tan squared x. So I make a T diagram and I look at what's the most complicated side first and see if there are any trig identities, basic trig identities that I can plug in. Well, right off the bat, I can do something here. So I'm going to put in secant squared x, leave that, minus tan x, but I'm going to use one of the reciprocal identities and put cotan x as 1 over tan x. Why did I do that? Because tan x times 1 over tan x is just 1. So this gives me secant squared x minus 1. Now, where do I have squared? I have that in the Pythagorean identities. I have that in the blue one, which is tan squared x plus 1 equals secant squared x. So let's put that in. Tan squared x plus 1, that's for secant squared x, and then I subtract 1, and that gives me tan squared x. Well, that's exactly what I was trying to verify, so that's done. We've proven it. Now let's try another one, and again I'm going to keep my list next to me, so I'll pin this page and move on to the next one. The next one is 7 sine theta plus 5 cosine theta all over sine theta cosine theta and that equals 7 secant theta plus 5 cosecant theta. I'm going to make my T diagram. Well, if I look at this, the two sides of this equation, first of all, the left side is a little more complicated. There's a little more going on. And the right side is two different terms. So how about this? How about if I break this into the left side into two different terms? So that is 7 sine theta over sine theta cosine theta plus 5 cosine theta over sine theta cosine theta. Now I can see right away the signs cancel here, and that leaves me with 7 over cosine theta plus, and here the cosines cancel, and I have 5 over sine theta. Looking at my identities, I see that I have 7 times 1 over cosine theta plus 5 times 1 over sine theta. But my reciprocal identities tell me that this is just 7 secant theta plus 5 cosecant theta. And I'm done because that's what I have on my other side. Let's try one more. This is the following. Let's try a different color for variety. Sine A over cosecant A plus cosine A over secant A equals cosecant squared A minus cotangent squared A. And again, I'm going to use my T diagram so that I keep the two sides separate in case I have to do something on both sides. So sine A times 1 over cosecant A plus cosine A times 1 over secant A. But using my reciprocal identities, 1 over cosecant A is just sine A, so I have sine A times sine A plus 1 over secant A is just cosine A, so I have cosine A times cosine A. Well, this is sine squared A plus cosine squared A, but that just equals, by the Pythagorean identity, that just equals 1. Well, that's not what I have on the other side, so now I have to see if I can change things around on the other side or use the identities in any way. Which identity relates cosecant and cotangent? That is the Pythagorean identity. So where I see cosecant squared using the red one, I'm going to put in 1 plus cotangent squared A minus cotangent squared A. Well, that just equals 1. And now I'm done. See you in the next